Mars is not a dead planet. That's the old story, the one we told ourselves for decades. The new story, the one that the data is actually telling us, is far more complicated and far more exciting. The evidence coming back from Mars right now is forcing scientists to completely rethink what they thought they knew about our nearest planetary neighbor and what might still be alive there. For as long as humans have looked at Mars through telescopes, we have wondered about it. It is our nearest planetary neighbor, close enough that on a clear night you can see it as a bright reddish point of light with the naked eye. It has seasons. It has polar ice caps. It has a day that is almost exactly the same length as Earth's. In the late 19th century, the astronomer Percival Lowell convinced himself, and much of the public, that he could see canals on Mars, vast engineering works built by an intelligent civilization to transport water from the poles to the equator. He was wrong about the canals. But the instinct that drove him, the sense that Mars might be inhabited, has never entirely gone away. And today, with far better tools than Lowell ever had, scientists are finding reasons to take that instinct seriously. Not because of canals, not because of intelligent life, but because of something far more fundamental. Evidence that Mars was once a very different world, and that the conditions for life may have existed there, and may, in some form, still exist today. Let's start with the past. About 3.5 to 4 billion years ago, Mars was a warmer, wetter world. We know this from the geology. The Mars rovers and orbiters have found ancient riverbeds, lake beds, and delta formations, the unmistakable signatures of liquid water flowing across the surface for extended periods of time. They have found minerals that only form in the presence of liquid water, clays, sulfates, carbonates. They have found evidence of a thicker atmosphere that could have sustained surface temperatures above freezing. Ancient Mars, in other words, looked a lot more like early Earth than it looks like the cold, dry, thin-aired desert it is today. It had rivers, it had lakes. It may have had a shallow ocean covering much of its northern hemisphere. And we know that on early Earth, in conditions very similar to what ancient Mars experienced, life got started quickly. So the question is not whether Mars could have supported life in the past. The conditions were clearly there. The question is whether it actually did. And that question remains open, tantalizing, and increasingly urgent. The Mars rovers, Curiosity and Perseverance, have been exploring the Martian surface for years, and they have found organic molecules. Carbon-based compounds, the building blocks of biology. Now, organic molecules can form through non-biological processes, so their presence alone doesn't prove life. But their presence is consistent with life, and it tells us that the chemistry was available. The ingredients were there. Curiosity has also found evidence of ancient lake environments that were not just wet, but chemically suitable for life, with the right pH, the right salinity, and the right energy sources to support microbial organisms. But here's where it gets really interesting, and this is the part that keeps astrobiologists up at night. Mars today has methane in its atmosphere, traces of it detected by both the Curiosity rover on the surface and by telescopes on Earth. And methane is a puzzle. In the Martian atmosphere, methane should be destroyed by ultraviolet radiation within a few hundred years. So if it's there now, something is producing it now. What? There are geological explanations. Certain chemical reactions between water and rock can produce methane. But on Earth, the vast majority of atmospheric methane is produced by living organisms. Bacteria, archaea, the digestive systems of animals. Could the methane on Mars be biological? We don't know, but we can't rule it out. And the fact that the methane appears to vary seasonally, rising and falling with the Martian seasons, adds another layer of mystery that no purely geological explanation has fully resolved. The search for an answer is one of the primary goals of the Perseverance rover, which has been collecting rock samples that are intended to be returned to Earth by a future mission. When those samples arrive, and scientists hope that will happen in the early 2030s, they will be analyzed with instruments far more sensitive than anything we can send to Mars. If there are biosignatures in those rocks, chemical or structural evidence of past life, we will find them. The Mars Sample Return Mission may be the most scientifically important mission in the history of planetary exploration. And there's another possibility that is even more intriguing. Mars today is cold and dry on the surface, but beneath the surface, things may be different. In 2018, the European Space Agency's Mars Express orbiter detected what appeared to be a subglacial lake, a body of liquid water beneath the South Polar ice cap, kept liquid by the pressure of the ice above and possibly by the heat of the planet's interior, or by the presence of dissolved salts that lower the freezing point of water. If confirmed, this would be a remarkable finding, because liquid water beneath the surface of Mars, insulated from the harsh radiation and extreme cold of the surface, could potentially support microbial life today. Not ancient life, present life. The idea that Mars might harbor living organisms right now, not on the surface but hidden underground, is not fringe science. It is a serious hypothesis, taken seriously by serious scientists, and the implications of confirming it would be almost impossible to overstate. If we found life on Mars, even a single bacterium, even a fossil of a microbe that lived billions of years ago, it would be the most important scientific discovery in human history. It would tell us that life is not a one-time accident that happened only on Earth. It would tell us that the origin of life is a natural, repeatable process that occurs wherever conditions allow. It would transform our understanding of biology, of planetary science, of our own place in the cosmos. Every textbook would need to be rewritten. Every philosophical and religious tradition would need to grapple with the implications. And it would raise an immediate and fascinating follow-up question. Did life on Mars and life on Earth share a common origin? We know that rocks are regularly blasted off Mars by asteroid impacts and travel through space to land on Earth, and vice versa. Could life have hitched a ride? Could we be Martians? Or could Martian life be our distant cousins, seeded from the same source? The field of Panspermia, the idea that life can travel between worlds on rocks, is taken seriously by mainstream scientists, and a discovery of Martian life would immediately put it at the center of the conversation. These are not idle speculations. They are real scientific questions that a discovery of Martian life would force us to confront. And the missions currently exploring Mars are bringing us closer to an answer with every passing day. In the next episode, we're going to turn our attention to a world that most people would never think of as a candidate for life, a planet that is, in many ways, Earth's evil twin. A world of crushing pressure, sulfuric acid clouds, and temperatures hot enough to melt lead. And yet, scientists have found something there that they cannot explain. Venus is next, and what's been detected in its atmosphere is one of the most controversial findings in recent science. Don't miss it. Subscribe and keep watching right now.